Imagine this. An object the size of Manhattan is flying through our solar system at 246,000 kilometers per hour. It came from another star system, from a place we might never see again. And in the last 48 hours, new images have revealed something scientists have never seen before. Something that's making even the most skeptical researchers stop and think twice. This object is not behaving the way it should. And with every new observation, the questions just keep getting more unsettling. On November 8, 2025, astronomers captured images that changed everything. 3i Atlas shows 7 complex jets shooting out in multiple directions, some of them pointing directly at the sun. A feature so bizarre that it breaks what we thought we knew about comets. But here's the part that's going to blow your mind. These jets stretch out for more than 1 million kilometers and stay perfectly collimated, not smeared out by the rotation of the object, which spins once every 16 hours. Think about that for a second. For material traveling at the normal thermal speed of a comet, around 400 meters per second, it would take an entire month to cross that distance. During that time, the object would have spun more than 40 times around its axis. Those jets should be blurred, spread out like water from a garden hose when you spin it around. But they're not. They stay sharp, precise, directional. How is that even possible? And there's more. Recent spectrographic analyses from the Very Large Telescope showed that the comet is emitting pure nickel with practically no iron, a chemical signature that, until now, has only been seen in industrial processes on Earth used to refine nickel through the breakdown of nickel tetracarbonyl. No, you didn't read that wrong. Industrial processes, in deep space, coming from an object that might be 7 billion years old, older than our own solar system. Let's take a step back. What do you usually think of when you hear the word comet? You probably imagine a ball of ice and dirty rock, a frozen relic from the early days of the solar system. Maybe you think of Halley's Comet, coming back every 76 years like a cosmic clock. Or maybe you've seen photos of those spectacular tails tearing across the night sky, always pointing away from the sun as solar radiation pressure pushes that sublimated ice outwards. That's how comets work. At least that's how they've always worked. 3i Atlas was discovered on July 1st, 2025, by the Atlas Survey Telescope in Chile, entering the inner solar system at a speed of 61 kilometers per second relative to the Sun. It was the third confirmed interstellar object to pass through our cosmic neighborhood, after Oumuamua in 2017 and Tufai-Borisov in 2019. At first, it just seemed like another interstellar visitor. Exciting, sure, but understandable within our existing models. Scientists expected that, like Borisov, 3i Atlas would basically behave like the comets we already know. Maybe it would have a slightly different composition, maybe a few unique properties, but nothing that broke the fundamental rules. The international astronomy community mobilized. NASA missions like Stereo, SOHO, and Punch started watching the comet from different angles. ESA used the ExoMars Trace gas orbiter in orbit around Mars to improve predictions of the comet's trajectory by a factor of 10. It was a one-of-a-kind scientific opportunity to catch a visitor from another star system and study it in real time. But nobody was ready for what came next. The first sign that something was off came in July, when early observations started to show a strange feature. During July and August 2025, 3i Atlas showed a jet pointing toward the sun, an anti-tail that was not just a geometric optical illusion like we see in familiar comets. This was unusual. Comets don't do that. Solar radiation pressure pushes material away from the sun, not toward it. Some scientists tried to explain it as a perspective effect, a trick of light and angle. But more detailed analyses showed it was real. Then came the chemical data. Ultraviolet spectroscopic observations from the Very Large Telescope in Chile detected bright nickel vapor in the gas atmosphere around 3I Atlas. On its own, that wasn't completely unheard of. Nickel had been detected in other comets before. But when scientists looked for iron, which usually appears in similar amounts to nickel because both are formed together in supernova explosions, they found almost nothing. VLT observations in July and August 2025 showed a rapid, steady increase in nickel and cyanide concentration in the coma of 3I Atlas, but no iron vapor was detected, which is strange because nickel and iron are normally found in roughly equal amounts when they're released from comets. Scientists started firing off frantic emails. Emergency meetings were scheduled. Something wasn't adding up. This wasn't just a weird comet. It was a comet that seemed to be breaking fundamental chemical rules of the cosmos. Spectra obtained showed an abnormally high nickel-to-iron ratio, with strong nickel emission but weak iron, an intriguing imbalance that only started to normalize when the comet got closer to the Sun. And then came the perihelion passage, the point closest to the Sun, on October 29, 2025, at a distance of 136 astronomical units. That's when the object became temporarily invisible to ground-based telescopes, hidden in the Sun's glare. When 3I Atlas came out of that close encounter with our star, everything changed. On November 8, 2025, astronomers M. Yeager, G. Raman, and E. Prosperi from the ICQ Comet Observations Group observed the comet at 29 degrees of separation from the Sun in the sky. And their images revealed a complex structure of jets, with at least 7 jets, some of which were anti-tails. One day later, on November 9th, Frank Niebling and Michael Buchner from the British Astronomical Association captured a composite image using 2 telescopes that showed a long, smoky tail and 2 anti-tailed jets. Scientists started debating furiously about what they were seeing. 3 main hypotheses emerged. Hypothesis 1. Natural fragmentation. Maybe the nucleus of the comet partially exploded during perihelion, throwing fragments out in several directions. That could explain the multiple jets. Some comets do this when solar heat vaporizes internal ice too quickly, creating pressure that cracks the frozen surface. But there was a problem. The image taken by D. Jewett and J. Liu on November 11th showed a single object, not multiple fragments, contradicting the idea that the nucleus had blown apart. Hypothesis 2. Pockets of ice with exotic chemistry. Another possibility was that 3I Atlas has pockets of volatile ices with unusual compositions on its surface. Formed in another star system under totally different conditions than ours, the comet could contain types of ice that just don't exist in solar system comets. Over millions of years in interstellar space, cosmic radiation could have further altered the ice chemistry, producing physical behavior very different from what we see in native SETI comets. That would explain the weird nickel chemistry. Processes involving nickel carbonyl, which refine nickel through the formation and breakdown of nickel tetracarbonyl, could be happening naturally near the core of 3I Atlas, leading to a strong local concentration of nickel. Plausible, but it still didn't explain the jets. Hypothesis 3. The non-natural possibility. And then there was the most controversial hypothesis of all, mainly defended by Avi Loeb, a theoretical astrophysicist at Harvard and director of the Galileo Project. Loeb put together a list of 12 anomalies about 3I Atlas, including its retrograde trajectory aligned within 5 degrees of the ecliptic plane, with only a 0.2% probability, its nucleus being about 1,000,000 times more massive than Oumuamua while moving faster, and its arrival time being finely tuned to bring it within tens of millions of kilometers of Mars, Venus, and Jupiter. Loeb suggested a more speculative possibility. The jets keep their direction because they're being produced by technological thrusters that preserve the object's overall orientation for navigation purposes. The established scientific community reacted quickly. Tom Statler, NASA's lead scientist for small bodies in the solar system, said, "It looks like a comet. It does comet things. It very strongly resembles, in pretty much every way, the comets we know." But even the skeptics admitted the data was disturbing. The real turning point came when astronomers finally finished fully processing the latest images. Observations from November 9th showed jets extending to distances greater than 1,000,000 kilometers, but still tightly collimated, even though 3I Atlas spins with a period of 16 hours. Do the math. At the expected thermal outflow speed of 0.4 kilometers per second for a natural comet, the material would take about a month to travel that far. During that time, the comet would complete more than 43 full rotations. If the jets were being created by simple ice sublimation, the standard comet process, they should be smeared into a circular pattern as the object spins. It's like trying to paint a straight line on a spinning ball. Impossible. And yet, there they are. Sharp, directed, keeping coherent structure across a scale of millions of kilometers. Loeb calculated that for the anti-tailed jets to only be stopped at a distance of about 1,000,000 kilometers, their dynamic pressure would have to exceed that of the solar wind out to that distance, with the outermost mass density in the anti-tail being 1,000,000 times greater than that of the solar wind. That is not normal comet behavior. That's something different. Here's what the new observations tell us. If 3I Atlas is a natural comet, it's operating under physics we don't fully understand yet. The combination of industrial-like chemical composition, jets unaffected by rotation, persistent anti-tails, and statistically unlikely orbital timing creates a puzzle that no single theory can explain in a satisfying way. Unistellar data showed an unexpected increase in brightness before 3I Atlas became invisible, suggesting a major change in the comet's physical state, with that brightness increase persisting through perihelion, as confirmed by space-based solar observatories. We're not saying it's an alien ship, but we are saying that this object is forcing us to rewrite what we think we know about how interstellar objects behave. Every new observation doesn't solve the mystery. It makes it deeper. So what does this really mean? 3 Atlas may have come from the thin disk or the thick disk of the Milky Way. If it came from the thick disk, the comet might be at least 7 billion years old, older than the solar system itself. Think about that. This object may have formed before our planet even existed. It has traveled through interstellar space for eons, witnessed the formation of star systems, maybe even seen stars being born and dying. And now it's passing through our cosmic neighborhood, giving us a brief window to study something that comes from a totally different place and time. The comet came closest to Earth on December 19th, 2025. At a distance of about 1.8 astronomical units, roughly 270 million kilometers. After that, it will continue its journey back into interstellar space, never to return. This is our only chance, our only opportunity to understand this visitor and what it tells us about the universe beyond our little cosmic backyard. Additional observations were scheduled from missions like ESA's JUICE in November 2025 and NASA's Juno in March 2026, but the window is closing fast as the object moves away and grows dimmer. The implications go beyond scientific curiosity. If objects like 3I Atlas are relatively common, and there's evidence they might be, then we're constantly being visited by ambassadors from other star systems. Professor Avi Loeb has argued through the Galileo project that scientists should at least consider whether the object could be a technological artifact or probe from another civilization. Most scientists reject that specific idea, but nobody dismisses the bigger question it raises. What else is out there that we still don't understand? How many other objects like this have passed by unnoticed? How many will pass by in the future? Even though 3I Atlas poses no threat to Earth, multiple NASA spacecraft studied it, so scientists could learn as much as possible about this interstellar visitor before it leaves our solar system and heads back into interstellar space, never to return. Here's the humbling truth that 3I Atlas teaches us. The universe is much stranger, much more complex, and much more surprising than our current theories can capture. Every time we think we understand the rules, nature shows us there are deeper layers of mystery waiting. This interstellar visitor, with its impossible jets and alien chemistry, isn't just a curious comet. It's a cosmic reminder that we're rookies trying to understand a cosmos that existed for billions of years before we ever opened our eyes for the first time. The November 2025 images of 3I Atlas don't just capture a distant object crossing our sky. They capture the moment we realize, once again, that the universe is stranger than we can imagine. And maybe, just maybe, that's exactly what makes space exploration so vitally important. Because if we don't look up, if we don't pay attention to the visitors that pass by our cosmic doorstep, we'll never know what secrets they carry, we'll never understand where we came from, and we'll never figure out where we're going. 3I Atlas is leaving. But the questions it raises about alien chemistry, about strange comet dynamics, about what else is traveling between the stars, those questions stay with us. And as we look up at the night sky, knowing that something from another star system is out there, invisible but real, we're forced to face a fundamental truth. We're not just observing the cosmos. The cosmos is also observing us in the form of every visitor that passes by, every messenger from distant worlds. What is 3I Atlas really? A comet with extraordinary properties? A phenomenon that demands new physics? Something else? Honestly, we still don't know. And in a way, that's the most exciting answer of all.